We're recording. Okay, a quadratic function is a function of the form y equals ax squared plus bx plus c. Okay, a quadratic function, y equals ax squared plus bx plus c. You saw this in Algebra 1 and Algebra 2, so we're going to go over this briefly. We're actually not going to do our graphing calculators in example 1 because we already know this. If you make a little sketch of y equals x squared, then what do you know is going to happen with y equals 2x squared?
Vertical stretch.
Good. It's going to be a vertical stretch. It's going to be a little bit skinnier than that one. And then y equals 8x squared is going to get really skinny, a vertical stretch, okay? And then in letter B, I start with that parent function. And if I do y equals 0.8x squared, that's going to make it a little bit wider, or a vertical shrink. And then the 0.2 is even wider, okay? And then what happens in letter C when you put a negative out front? It flips it upside down, and a negative 2x squared flips it upside down, but it's skinnier, okay? So the big idea here is if A is between 0 and 1, it's wider or a vertical shrink. When A is greater than 1, it's narrower or a vertical stretch. When A is negative, that causes it to be a reflection over the x-axis. Alright, so these are things we already know, but just briefly summarizing. The vertex of a parabola can be found by doing x equals negative b over 2a. If it's in standard form, y equals a times the quantity x minus h squared plus k. You can determine the vertex by h comma k. Alright, so just a real brief review. X equals negative b over 2a is when it's in y equals ax squared plus bx plus c. I'll tell you, this is a little confusing. We've already seen it once already with our direct variation, why they use the letter k, I don't know. The other thing this book does, they call this y equals a, the quantity x minus h squared plus k. They call that standard form, but in any other book, y equals ax squared plus bx plus c is standard form. So what I'm going to do on any quiz or test is I'll say standard form, but I'll put a comma and I'll write out the form I want, so there's, that'd be easily confusing. So I'll try my best on my end to make that clear. And if you get a quiz and I didn't do it, just raise your hand and I'll clarify it for everybody. Okay, so sketch the graph of f of x. What?
Best graph ever.
Oh, that look weird. That's cool. F of x equals 2x squared plus 8x plus 7 by writing the function in standard form. This means f of x equals a times the quantity x minus h squared plus k. So let's do that. The first thing we're going to do is we're going to subtract 7 from both sides of the equation. And really, when you see that standard form, you should be thinking completing the square. Because we're trying to get it as x minus h, the quantity squared. Leave a little bit of space here so we can be proactive. In order to complete the square, you need to have the x squared to have a 1 in front of it. So you want to usually factor out whatever a is. So I'm going to factor out the 2, and notice that changes the inside to x squared plus 4x. I'm not factoring out a GCF, okay? I'm factoring out the A so that I can complete the perfect square. So then remember, you take half of 4, which is 2, and square it. But I didn't actually add 4 to the right side. What did I actually add? 8. How did you get 8? Yeah, do you see that? That inside here it really is getting multiplied by 2, so I'm adding 8 to both sides. So this becomes f of x plus 1 equals 2 times the quantity, x plus 2 squared. So I completed the perfect square trinomial. And then the last thing I'm going to do is subtract the 1. Now it's in standard form, and I can read off the vertex is -2, -1. Now let's make a table. Remember with parabolas, we do a table with 5 rows. And look at your equation and look at these numbers. Which of the 4 remaining table values would be the easiest to plug in? 0, right? 0 is our friendly number. If I plug in 0 up here, what's the y value? 7, okay? And isn't that also the y-intercept? When x is 0, the y value you get is the x-intercept. All right, now you can choose between -1 and -3. I'm probably going to go with -1. This is going to give me 2 times -1 squared plus 8 times -1 plus 7. I'm just plugging it in, and you could plug it in over here if you'd like. That works too. But remember, please excuse my dear Aunt Sally, I can't multiply these first because an exponent comes before multiplication. So that's 2 times 1, and then that's 2 minus 8 plus 7. That's -6 plus 7 is 1. Now think about this. My x values are 0 and then to the left, and I apologize, I don't know what happened to my grid. So I have 0, 7, -1, 1, -2, -2, -3, 1, -4, 7. And so we have symmetry with respect to your axis of symmetry. So let's include that. My axis of symmetry is always a vertical line. Vertical lines are described by an x equals equation. And please draw your axis of symmetry. Now if you remember, we talked earlier in chapter 1 about graphing. And something you need to include with a graph are your intercepts. Well, we can tell the y-intercept is 0, 7. But the x-intercepts are not at -1 and -3, even though they look awfully close there. They're clearly not because they're in my table. So what we're going to do is we're going to take out our graphing calculators, and we're going to go to our y screen, and let's plug this equation in. 2x squared plus 8x plus 7. Okay, go to your y screen and plug that in, and let's do zoom 6 because we may not remember what we did last. And we're going to review the feature of how you find the x-intercepts. What's another word for x-intercept, John?
Zero.
The zeros, okay? So you're going to do second trace, and we're going to find the zeros. Zeros are X-intercepts. So I'm going to go get the one on the left first. So I'm getting negative 2.787. Let's go get the one on the right side. So you do second trace 0. So obviously this would be a calculator problem. And I'm getting negative 1.293. Alright, so I have my intercepts, my vertex, my axis of symmetry, and I have it graphed, and I graphed my axis of symmetry. Okay? Any questions on this? Alright, then let's look at example 3. So we're going to go ahead and practice putting this in the vertex form. And I'm going to multitask here. I'm going to add 8 to both sides, and I'm going to factor out the negative sign because A is not positive 1 right now, it's negative 1. So if I factor that out, I want you to notice that that actually became a minus 6x inside the parenthesis. And that's going to make a big difference if you get your sign wrong to the vertex. It'll be on the opposite side of the y-axis. So I take half of 6, which is 3, and I square it. But what was the net effect to the right side? Say it again. Good job. It's actually minus 9 because of the minus out front. So this is g of x minus 1 equals a negative the quantity x minus 3 squared. And then I'll just add the 1 to both sides. So the vertex is 3, 1. While I'm there, I might as well write the axis of symmetry. It's a vertical line, it's an equation. If you put 3 down, I'm going to mark it wrong, especially in a pre-calculus class. We should know the number 3 does not describe a vertical line. It's x equals 3. Alright, so then let's make a table of values. This is g of x. I think plugging in 1 might be easier. So this would be a negative, and then my 1 is being squared, plus 6 times 1 minus 8. 1 squared is 1, but it's a negative out front. You can't take that negative in because that's multiplication, and you don't multiply before the exponent. So that's 5 minus 8, which is negative 3. And then let's plug in the 2. So negative 4 plus 12 minus 8. Isn't that 0? So guess what? I actually got my x-intercepts right in my table, which is lovely. So let's identify it though. That's 2, 0, 4, 0. My y-intercept, have you noticed the y-intercept is always the constant when it's in ax squared plus bx plus c form. So the y-intercept is 0, negative 8. Alright, don't forget your axis of symmetry. Okay, any questions on graphing a parabola? Alright, example 4. A baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given by the function f of x equals negative 0.0032 x squared plus x plus 3, where f of x is the height of the baseball in feet and x is the distance from home plate. What is the maximum height reached by the baseball? Well, something you need to notice is when you look at that equation, you should be able to tell it's a parabola opening down. So where on the parabola are you going to find a maximum? At the vertex, okay? So it's going to occur at the vertex, and if you remember, a vertex is found when it's in this form, ax squared plus bx plus c, it's at x equals negative b over 2a. But are we looking for the x coordinate or the y coordinate? The y, because y is the height of the baseball. So we have to find x, and then we're going to find the y. So this is negative 1 over 2 times negative 0.0032. Now, what I want to do is I want to show you a technique on your calculator, but also make sure we know how to do this. So, get to your home screen, and you're going to take negative 1 divided by, and if you have a product in the denominator, you need to put a parenthesis around it. It's 2 times negative 0.0032, and then close the parenthesis with the product. You don't want to make it divided by 2 and then start a parenthesis, because then you're telling it to take negative 1/2 and multiply 1/2 by negative 0.0032, and that's not what you mean. So press enter, and then watch this. I believe I showed you this last year in Algebra 2, but in case we forgot, you can press store and X. Whoops. You only needed X once. Okay, hit store and X. We've just told the calculator that X has a value of 156.25. Now what we're going to do is we're going to let the calculator do the hard work for us. And you're going to type in the equation, negative 0.0032x squared plus x plus 3. And it's going to spit out the y value for us, okay? So you can use this feature, okay? We just told the calculator, here's x. Now plug it in for us. Thank you very much. So, the vertex is 156.2, and that was 81.125, something like that. So now, you need to make sure, though, in a word problem, is that you actually answer it. If you give me the ordered pair, I'm going to take a point off because that tells me you don't know what you were trying to find. The maximum height is 81.125 feet. And it does occur when you're 156.2 feet from home plate. Okay, that does occur there. All right, any questions on that? But you do want to think about, what are you trying to find in the vertex? Is it the x coordinate or the y coordinate? All right, go ahead and try example 5, A and B. I'll give you a head start. And then we're going to do some word problems to see if we really do understand this.
No, it's not too easy.
Okay, letter A, you start by adding 1 to both sides, and then to complete the perfect square, you take half of 4, which is 2, and square it, and then subtracting your 5. Alright, letter B I thought would be a little bit more difficult. You subtract the 21, and then you want to factor out the 4. And so when you do that, be careful because that's x squared minus x. So you're going to take half of 1, which is 1/2, and you square it. Now when you square a number, like if I took 5 and I squared it, you know that's 5 times 5. So if the same property holds, if I'm going to take 1/2 and square it, that's 1/2 times 1/2, which will be 1/4. But what was the net effect to the right side? Plus 1. Good. So you're going to add 1 because 4 times 1/4 is 1. So this is y minus 1 equals 4 times the quantity x minus 1/2 being squared.
Wait.
What?
It was 21.
You may have dropped the 1 on the
Oh,
21.
I did. Thank you. Thank you. I did.
That's what you're supposed to do.
Yeah, you just do that. Okay, sorry. Minus 20. There we go. Thank you. I've been also having trouble with my pen all day. It's like doing some wacky things. All right, so I get y equals 4 times the quantity, x minus 1/2 squared, plus 20.